can say g'day to our. Hang on, still going live. Now we're live. We can say g'day to Zebulon, who appears to be the only person in the channel, apart from us. G'day Zebulon, how's it going? Brian's logic is not so logical, you try and tell me.
No.
Yes, see if I can find his video. Was it a video or just in a...
Yeah. Well, it's fairly impressive though that he can go through something as complicated and complex as GPS actually is, and manage to get absolutely nothing right. Nothing right. You would think the law of averages, when you've got that much to choose from, eventually you would mess up and, something would click. Nope.
Nope.
Not with Brian. No.
I'm trying to find it. How long ago was this? Any ideas?
You brought it up, Alan. Was it?
Oh, it's all over your Discord server.
Oh, yeah. Okay. I'm just trying to find.
Yeah.
Must be a. Let's have a look. Flick through your Discord server. I'll flick it up on the channel so anyone watching can console.
Yeah.
Discord. BMS Discord.
There
we
go. And suggesting GPS uses a directional antenna to find the azimuth to the.
Oh, really?
Oh yeah.
Yeah, I mean, I might have posted a picture of an antenna, of a very directional antenna, that can actually do really well because it can do like a beam width of half a degree. The problem with it is, I'm afraid I have to use old measurement.
You're right.
Money because of when it was built. It's 60 feet wide, 23.5 feet high just for the reflector, and the whole thing weighs 60 tons.
Yeah.
And that's kind of the dimensions you're... Oh, and of course, it will receive a signal down to the hundreds of microwatts. The time... you can feed a signal through to the receivers at about 100 microwatts. And physics says it's kind of got to be that big.
A few days ago. Yeah. I haven't seen him then. He could be anywhere. Let me try another thing. I often get my videos from Mr. 42's channel, and he's usually pretty good for finding. Let's see if we type in Brian. See what we get.
I'm not sure if this was on Brian's channel. This may have been
on something else. Oh, let's try it on yours. We can wander through. We go to yours. I'll do a search for Brian and see what people say. Maybe we get a bit of a sense where it was. Brian, so that was today. Brian, so you go back to how GPS works. Doesn't say where. Nerd alert. That was GPS. Be interesting to see. Well, maybe not. Who knows? I'll have to track it down. I might track it down for the weekend show. They're still talking about that submarine.
Well, I think news about it keeps dribbling out, doesn't it?
Takes craft around 2 hours to send. Yeah. What's
And
not a
and
news.
and I
Go on.
and I
Yeah.
don't like to say it. It seems like people keep leaking information on it, don't they?
Yeah. Yeah. Not quite the tone of phrase I might have used for that.
I know. It's like yes, but I'm sorry. I didn't. You know, I wasn't trying to be disrespectful.
No, I
but
know. It's all right.
What other term can we use?
I got it. It's not quite something else out there, is there? GPS can't work on the flat Earth. No. Well, it could, but the question is, how do you keep the satellites or whatever up and in the same spot? That's the question. That was Zebulon's GPS can't work on the flat Earth.
Yeah. No. Actually, it's how do the stationary buoys in the sea, because obviously that's how they must be doing it.
Yeah.
From the because it's all towers. How do they fake the Doppler shifts that you can quite easily measure on the signals coming from those transmitters?
There's lots of reasons to say that's definitely not flat Earth, but if you were going to do it on a flat Earth, how would you do it? If you just did it from towers, that wouldn't be a very good, reliable system.
I think what Alan's referring to is over on Quantum Eraser's channel.
QE. Okay. Let's see. Quantum Eraser. Does he go by Quantum Eraser? He must do. Surely. In YouTube. I, funnily enough, don't have him as a subscribed channel. This. Yeah, that's him, isn't it? So hang on, let me put it up. Where's Chrome? There's Chrome. This is his channel, right? Yeah, there we go. That's kind of racist channel. Yeah.
Look at live streams.
Okay, let's go. Live streams, QE Lives, Natural Science Method, Ballbusters. That was 14 hours ago. That's a bit too recent, isn't it? So.
Yeah.
Jurism. Someone must have said in there. It looks like this one looks promising. See the.
Might be it. Yeah.
The towers. Quantum Racer, Ballbusters, Nathan Oakley.
How GPS actually works.
Yeah. Let's see if the. Can we skip any? Okay.
Scroll on over there.
Yeah, it's got to be.
Oh yeah, that's him.
Let's go here.
To get into the weeds.
Oh, can you hear that?
Figure stuff out.
Yeah. Just got to change a couple of settings so that you can hear that. Playback into.
We heard it.
Oh yeah, no, but it's coming out.
They heard it.
No, it's coming out into my household, and I don't want to subject that to the people in my place. It's coming through my speakers rather than my headphones. Sorry.
I have no problem with that.
That's when you get members of your family coming into the house and coming home because you were home without anybody to disturb, and asking you if you are you arguing with R words again?
Yes. My daughter was quite upset. She said, "Dad, you were shouting." And I'm saying, "I wasn't shouting." He said, "Yeah, I don't like it." And apparently I was animated. Well, for me, because I'm usually a fairly quiet-spoken person, so anything above what I'm speaking now is considered, animated for me. Hang on, let's put that on.
But this might be useful for many people out there. So I would pay attention. Brian, are you ready?
Yes, Kiwi, I am ready to go.
Good, I'm not. All right, yeah, I am ready. So
Are you Slide Waller again this evening?
I'm the slide man.
Eat your slides, man. You're gonna have to be paying attention. No slipping off for drinks, nothing.
Yeah, I know. Isn't that a bummer? But we're gonna.
Yeah, let's get through a little. Here we
No
go.
worries. Okay, thank you. Thanks for having me on to do this presentation. Okay, the first section of this presentation, the presentation is called How GPS Actually Works. Section 1 of this
Actually
is
works.
on surveying OS mapping, which is ordnance survey mapping, and coordinates. This
Is in the Flat Earth word, the words how something actually works is how I made it up. Is that seems to be
Correct.
It's not how it actually works, it's just something I made up.
is harking back, this first section is harking back to presentations I did on surveying 4 or 5 years ago, where I brought in the coordinates that they use, and also I brought GPS into it back then as well, and pointed out things concerning the coordinates that they use, that GPS uses. That means that they can't be referring, GPS can't be and isn't referring to a spherical Earth. Now, I'm not saying mathematically. So this is what I'm going to see. This is the whole point of the presentation. I'm going to the main argument that we get concerning GPS is that GPS only works on a globe because it's purely global in what they give you. It's a globe, and there's satellites that orbit this globe in a vacuum of space. Blah blah blah. But I'm going to show here. I'm going to give a case for both towards the end. I'm going to show here how there's big problems with it working on a globe, even as they say how it works. So even if we were on a globe, how they say it works wouldn't work. That's the point, right? But I'm going to show how it actually works and how that supports flat more than globe. Okay, so I'm not going to give too much away at the start. Okay, why I'm starting with surveying is this. When I read up on surveying years ago, on more than one official source
So it's an
stated
expert now.
that GPS was first used in surveying in 1994. And I know for a fact that GPS was first used in Ireland by surveying in 1993 into 94. And how I know that is my mother's partner is a retired geodetic surveyor. Now, he's an older man, and so he retired back in 93 into early 94. I think it was actually late 93. But he was telling me about the younger surveyors that were working with him at that time who were using GPS, right, for surveying back then, right? And they had the receivers, and that was coming into it back then. So I know for definite that if that was being used in Ireland in surveying back in 1993, or being brought in 1993, then that means it was definitely being used in the United States, Britain, elsewhere, right? Because if it's being used in Ireland, it's definitely started in the US or somewhere else, because GPS started in the US. That's what they say. Now,
Never occurred to him, of course, that maybe they had to test it out and make sure it was actually good before they started using it all the time.
Yeah, and of course that was in the days when the US military encrypted a bit of the signal so that you couldn't get particularly good accuracy off it anyway, even when you had the really accurate stuff.
Yeah, well, I know when we first time I saw it used, we only used it to position the base stations, and then we created a local network to do the more detailed stuff, because it took too long to get an accurate measurement to do any feature surveying. And that was in the early 90s.
I know that since they took the encryption away, archaeologists have been having problems because all their previous GPS surveys now no longer work
Oh, okay.
because they can't go back to the point where they were because the precision change happened. It
Yeah.
literally moves points. It literally moves locations around.
But that's sort of archaeologists are patient people. I'm sure they'll work it out.
Yeah,
Only
they go
raised
back to theodolites and total stations.
Well, they should have marked it better on their map, shouldn't they?
Well, once they find the actual point, then it's not a problem. It's just, you know, because effectively the network has changed. They've got to line up the old system with the new system.
Yeah. Now, let's see what he's got to say.
that GPS was given to the public in 1995, released to the public by the US military in 1995. Now, I'm not denying that the US military had the use of GPS maybe before surveyors had it, but the
Maybe.
evidence mounts more towards
Maybe.
surveying being the
Brian,
originators of GPS, or at least they were.
Jesus, Brian. Brian is so full of shit. The first handheld GPS available to the public was a device by Magellan, and it went on the market in 1989, Brian, not 1994.
Yeah. Yeah, I just thought that was funny. Oh, maybe the military had it. Of course, yeah, it's like
the Magellan.
Magellan was pretty early.
The Magellan civilian GPS first went on the market for sale in 1989. Look it up.
I bet they were rather expensive back then, weren't they?
Yeah, they were pretty pricey. Yeah. So was an HP 45 handheld computer.
Yeah, I remember I used to use a HP 45, and
Yeah.
I daisy chained them. That was my first CAD system, and yeah, back in when those things first came out, and you started using it.
I
with
still got
coding.
one. Yeah, when they came out in the early 70s, they cost $400.
Yep, they were not cheap.
You could buy a damn good used car for what that silly pocket calculator costs.
Well, actually, when I say I had one, I actually had never owned one, but the boss used to have them. Had few of them for us to use for calculations and stuff. I didn't actually own one myself. That was like, $400 then was like, a couple of weeks' salary. It was not getting one. Yes. Brian, what else you got to say?
Were using it prior to it supposedly being released to the world. Because how can it be released to the world like a big secret came out in 1995 kind of thing when it was being used in Ireland in 1993 by Surveyor?
It wasn't a big
Surveying
secret,
is
Brian.
directly connected to GPS, and that's what I'm going to go through in this first section. And how, well, basically, GPS wouldn't exist without two things. One, celestial navigation. Two, surveying. Other than that, there wouldn't be GPS. So, okay, next
Right,
slide.
before you start, Brian, just because only because it's $20 super chat from James May. So there's good day to the panel. Thank you, James.
Hey, thanks for coming, James. James is a busy man. Appreciate it.
Yeah. Otherwise, it will slide by. It came literally as you were just starting. Now, I've just thought 7 minutes for the first slide. 7 times 80.
Don't worry about it.
I'm not any ribbing you. I'll shut up.
I was thinking the same exact thing. I said, okay, 8 minutes for the first slide. We're going to get out of here in late 2027.
No, it's just I must stress this point concerning surveying, because if more people had paid attention to my presentations on surveying some years ago, then this part wouldn't be. It's not for the basic panel members. It's for the general public out there. At the time, they didn't pay attention to it. I did it on a couple of different channels, and people were more busy with arguing in the chat with George Netchuk and Blue Marble Science and Rumpus and whoever else instead of paying attention. That
Yes,
was what was
you-
wrong. Okay, so that's not an indictment on the people listening now. I'm just saying at the time that's what happened.
That's 12 minutes on the first slide, so it's late
Yeah.
2029.
Okay, right. Slide 2, please. Or next slide. Okay. Primary divisions of surveying. Plane surveying. Type of surveying in which Earth's surface is considered as a plane and the curvature of the Earth is ignored. In such surveying, the line joining any two stations is considered to be straight. Geodetic surveying. Type of surveying in which the curvature of the Earth is taken into consideration. The line joining any two stations is considered as curved line. Next slide, please. This is an XYZ Cartesian system. This is a three-dimensional XYZ Cartesian system. This is a representation of that. It's basically a cube. Think of it.
You like
How
that?
would it be anything other than three-dimensional?
Yeah, I was going to say,
Brian?
I'd like you to show me a two-dimensional XYZ system.
This is an XYZ two-dimensional system. Yeah,
Yeah,
Well,
that would be
come
lovely.
on, it is being represented in 2D to us.
it is.
Actually, it is.
But yes, I
Sorry.
think that. No, I thought that was funny when he said it too. It's just like, why would you say, oh, this is three-dimensional? The three-dimensional XYZ system. Okay.
As opposed to what?
Yes. Yes,
It could be
Go.
ABC.
it could be. Anyway, let's see where he goes. I assume 0 is meant to stand for origin in that diagram.
Yeah.
You'd think so, yeah.
As a cube. Sometimes it's a rectangle, but think of it as a cube. Okay, next slide, please.
Sometimes there's a rectangle.
Cartesian reference system. It is this. I have some slides, so I have to do a little bit of reading, but like only maybe 3 or 4.
Yeah, that's fine. You're good.
It is important to realise that the centre of a Cartesian reference system for an adopted ellipsoid may not be the true or adopted centre of mass of the Earth. The latter is often used for global reference systems as used by the Global Positioning System GPS. Furthermore, the direction of the Z-axis may differ. This has led to one of the major requirements of geodesy and surveying today, which is how to relate global to local referencing systems so that positions in one may be expressed in terms of the other, and vice versa. This issue is not dealt with here, except to state that it is necessary to move from the ellipsoidal system to the local Cartesian reference system before applying some translations in XYZ and possibly scale, change, and rotations around these axes as well to move from the local system to global. The Cartesian reference system is particularly useful as calculations are simpler to
Death
perform.
by PowerPoint,
No
Brian.
knowledge of spherical geometry being required. However, the relationship between positions on the Earth's surface are different to visualize in this system, and this is particularly important in navigation. For instance, the concept of height is also unclear. What they're talking about here is they want to normally try and use spherical coordinates from the center point of a globe, right, out to points on the surface of Earth. But when they're dealing with reality, then they must use a horizontal plane. So basically what they're
Doesn't
admitting
say
here,
must at all.
without
Where does it say any of that? I know what he's trying to get at, but it's just not what it says. They don't have to use a horizontal plane. They just have to use the local. They translate it to the local, whatever local system you're using. You know, we don't use the same system here that they use over in the US, which they use and which is different to what they use over in Britain, which is different to what they use in India, which is different to what they use in South America. That's what that's about.
indicting them for being lawyers. I'm just saying they're admitting here that the system of spherical coordinates from a center point to points on the surface of a globe doesn't work in reality when we're actually surveying, when we're actually doing stuff, because we're dealing with a horizontal plane and elevations above and below that. So for that reason, they need to use XYZ on the surface of the Earth.
So what you're saying is the spheretard is a dangling participle?
Yes, it gets in the way. They can't use it. And as well as that, they claim it's an ellipsoid, which it's geometrically not.
Right.
Geometrically, it's not an ellipsoid, but they must claim it is.
So
But because it's an ellipsoid, go on. Yeah.
so the sphere tart is surplus to requirements, in other words.
Yeah, it's something they must add in afterwards mathematically.
Yep.
It doesn't actually have any reference to reality.
Yep.
But they don't really realize that's what they're saying. Next slide, please. Okay. Local tangent plane coordinates.
My question is, who is they? Sorry.
Probably Bev's favourite
OSI.
non-governmental organisation in the UK, the Ordnance Survey.
Ordnance Survey, yeah. I'm just curious. I wasn't saying that wrong. I'm just curious where he was getting his thing from. That would make sense. But I think it isn't this. Ordnance Survey IEs /
I think this is actually Wikipedia.
So Wikipedia.
God
So it's
knows
actually
where it comes
Wikipedia. Yeah, it's actually Wikipedia. So, yeah. Anyway. Move on.
Local tangent plane coordinates, LTP, sometimes named local vertical, local horizontal coordinates, are a geographical coordinate system based on the local vertical direction and the Earth's axis of rotation. It consists of 3 coordinates. One represents the position along the northern axis, one along the local eastern axis, and one represents the vertical position. 2 right-handed variants exist: east, north, up, ENU coordinates, and north, east, down, NED coordinates. They serve for representing state vectors that are commonly used in aviation and marine cybernetics. Okay, the next part here is axes. What that's talking about is the conversion from the Universal Transverse Mercator map, which is a grid, which is a grid, but that grid is made out of the all those lines all convert back to latitude and longitude. So that's not, we don't need to go into that. I just want to read what ENU coordinates and NED coordinates are and give an explanation on it. Local east, north, up, ENU coordinates. In many targeting and tracking applications, the local east, north, up, ENU Cartesian coordinate system is far more intuitive and practical than ECEF. ECEF is the spherical coordinates where I just mentioned a minute.
Did you mention why it's called east, north, up? East, north, south?
I think he just got.
Go on.
I think he just got that completely backwards. So, sorry to interrupt you.
Yeah, right.
Because he just said, he just basically said that the Cartesian coordinates were the spherical ones.
Yeah, well, that's not right. Let's go back. Just check if that's what he said.
Represents the position along the northern axis, one along the local eastern axis, and one represents the vertical position. 2 right-handed variants exist: east, north, up, ENU coordinates, and north, east, down, NED coordinates. They serve for representing state vectors that are commonly used in aviation and marine cybernetics. Okay, the next part here is axes. What that's talking about is the conversion, but that grid is made out of the all those lines all convert back to latitude and longitude. So that's not, we don't need to go into that. I just want to read what ENU coordinates and NED coordinates are and give an explanation on it. Local east, north, up, ENU coordinates. In many targeting and tracking applications, the local east, north, up, ENU Cartesian coordinate system is far more intuitive and practical than ECEF. ECEF is the spherical coordinates where I just mentioned a minute ago.
Oops. No, it is not.
Nope.
It is not
Told you.
spherical, Brian.
In
Okay,
fact,
Paul.
ECEF is Cartesian as it'll ever get.
yeah, and as far as I remember, the local east, north, up coordinate system is spherical, isn't it?
No.
No. It'd be local, wouldn't it?
No. Oh, yeah, it's the
Yeah.
it's the equivalent of our national grid, isn't it?
So, yeah, it is. My understanding. I don't use a lot of this stuff. Blue's probably a little bit more into this stuff. So, NED is what is what they use in aeronautics, isn't it? From my understanding. So, I could be wrong. Keep going, Brian. Keep going. Ah, by the way, Paul's got a bit of a couple of letters there. G'day, Paul. I meant to say it. Didn't see you sneak in there, but I heard you.
Yeah. I've been a bit busy.
So, if you want to try...
East north up type coordinate system is a local coordinate system that's used for like our U.S. state plane coordinates or the British grid system.
Yeah.
Where you pick an arbitrary point and say, okay, that's the origin. And every point on the map is measured some distance from that point to the east and to the north. So you get northings and eastings, basically.
Yes.
Right. That's what that's all about. And normally they'll arbitrarily pick a point that is far off to the west of the box that they're looking at, to the west and to the south of it, so that there's never a negative coordinate.
Yes.
Yeah.
And they often usually hundreds of thousands of meters away from the likely bottom corner too. So, for example, our coordinate system here in Canberra, which was meant to be the Australian standard that no one used, is the origins down off the southern side of Victoria, so it's a long way away from anything close to where we are. But yeah, that's the origin, but that's not necessarily the centroid point. So when they create the plane, they balance that around the middle point too. Yeah.
It's just an origin point for that particular coordinate system that you're
just to say.
Local coordinate system that you're using.
0 is here. Yes.
Yeah.
And
I think the British grid all joins together.
Funnily enough, I was just watching a video by Matt Parker on this very on part of this very subject. I already knew that the origin for the grid is somewhat southwest of the Scilly Isles, which are the furthest southwest you can go within Britain.
Right.
Oh, sorry, within the UK. But also, our national grid is aligned to true north at 2 degrees west.
At the meridian. It's aligned with the prime meridian.
No, it's not aligned with the prime meridian. It's aligned with 2 degrees west, because 2 degrees west is a line that runs pretty much through the center of the country. It's the closest whole, it's the closest integer value line of longitude to the center of, to a line through the center of Britain. So they align it at 2 degrees west, not at the prime meridian. Because last November, because of the way magnetic north is moving, the point where true north, grid north, and magnetic north align actually came ashore from the English Channel onto the Dorset coast near Purbeck.
Okay, yeah,
And
now I follow.
And over the next couple of years, about the next 3 years, it's going to move north up 2 degrees west until it disappears off the coast at Fraserburgh in about 2026. And that's because the line of zero declination is at an angle to across the country and is moving east to west.
There you go.
Right. But you're
I
follow what you're
posted the
saying
link
now.
to Matt Parker's video actually in Level is Horizontal in your Discord, Blue, earlier on.
There you go. Paul, do you have a clue for your thing just before I start
I
playing
do.
again? Yeah. Let's pass that in there. Okay, let's see what else he's got to say with his.
I had something.
Oh, you did?
I follow what. Yeah, I follow some what Alan's saying, but magnetic north has nothing to do with your grid system. Nothing.
Correct.
Your grid
It-
system is
it-
aligned. Let me finish one time, please.
Sorry.
Your grid system is aligned with true headings. And maybe I didn't. I was thinking when you said 2 degrees west, you were talking about declination, but you're not. Okay, it's on a line. It's on the 2 degree west longitude line.
Yeah.
That's what you're saying. It's aligned to.
Yeah.
Yes.
Okay. All right. All right. I'm with you. Yeah. It looks like I've only seen a really gross, large scale map, and it looks like it's sitting right on the prime meridian on the cartoon I saw, but
It's
okay,
close.
2 degrees west. All right.
It
enough.
it would look close at where it is. Yeah. But Britain's so small.
But it's
it's
a beautiful one to show to our friend Bev, because then you say, okay, it's aligned with that one meridian. Why don't any of the other meridians line up with
the
that grid
grid.
system?
Yeah, that's right. They should do.
All of them. Yeah, all of them to the east of it slope from right to left, and all of them on the west side of it slope from left to right. What's going on with that? Oh,
Yeah.
I know. It's a globe.
Gloob. Oh, let's see what the expert else has to tell us about grid systems.
Geodetic coordinates. That would be latitude, longitude. The local ENU coordinates are formed from a plane tangent to the Earth's surface, fixed to a specific location, and hence it is sometimes known as a local tangent or local geodetic plane. By convention, the east axis is labeled X and the north Y and up Z, so X, Y, Z. Local
How do you have a
north, east,
tangent
down,
plane on a
NED
flat Earth,
coordinates.
Brian?
In an airplane, most objects of interest are below
Yeah. Yeah, what's it tangent to?
the aircraft.
Yeah, what's the
So
tangent?
it is sensible
What
to
is it?
define down as a positive number. The north, east, down, NED coordinates allow this as an alternative to ENU by convention. The north axis is labeled X, the east Y, and the down Z. To avoid confusion between X and Y, etc., in this article, we will restrict the local coordinates frame to ENU. So to explain why that's important, when they're saying that the XYZ is more
You're not showing the
practical
video, Timbo.
and intuitive
Oh, sorry.
than ECEF, is out-centered, out-fixed.
He hasn't
in
moved on
spherical
from his slide
coordinates
yet,
using
so,
an XYZ system from the center of a globe Earth of radius 3959 miles. The ENU coordinates is what mostly you will see, but if you're flying in an aircraft, you will be using NED. So east, north, up means that you read positive east, negative west, positive north, negative south, and positive up, negative down, right? For that coordinate. Up and down are elevations above or below sea level, right? Using ENU, right? That's what up and down is. Local northeast down, just one second, let me get this NED coordinates, northeast up. So that's read north first, positive, right? South negative, east positive, west negative, and down positive, up negative, because that's used with aircraft. So if I put in parentheses, let's just say for ENU, if I say, let's say, if I put in -2 plus 4 plus 4, right? That would be -2 west, plus 4 north, and plus 4 up for ENU. If I was to do NED,
Actually,
I would say, let's just say if I did the same things, it would be -2 would be 2 south, right, plus 4 east, and then plus 4 down, because they don't want someone in an airplane using coordinates that are based off of a ground, because that will confuse matters and maybe even cause problems in the air. So go on.
Uh, I don't use any D. So what, Blue? What's the zero elevation in any D in an airplane then?
Sea level.
So if you have a negative, you would have a negative height in what he just said then.
Yeah, you don't.
No, yeah,
Elevation and altitude's a reference to sea level, mean sea level usually.
Yeah.
Unless it's specifically said above ground level, that's okay what it means.
Yeah.
But any other altitude is above mean sea level.
Yeah, which is positive value.
Always.
Yeah, I'm trying to work out where you would have a negative value.
Well, I say always. It wouldn't necessarily be always. I mean,
No,
if you're
but yeah.
going to go land in Death Valley or the Sea of Galilee or the Dead Sea, yeah, you have a negative altitude then.
Yeah, but I was just trying to work out where you would ever have a negative D. Well, in an airplane that's 30,000 feet.
No.
So, yeah.
One out of it, up to date.
I don't want to hear that call from
Point-
ATC.
Questions on the,
Climb and maintain negative 10,000 feet.
Yeah, particularly when you're at 5,000 feet.
You want me to do what?
He's saying the way in which they plot these coordinates on the surface with the ellipsoid model is not to use the surface, it's to use the centre of, to take them to hell as the point of reference, and everything's from there, locate them, as opposed to like you would on a Cartesian grid, just use the grid.
Yeah, well, what they're doing is they're putting an XYZ at the center of a globe Earth, and that's called ECEF, or Earth Centered Earth Fixed. And they'll take, that's
Yeah,
what
that's
they
what I'm
do
saying. So it comes,
afterwards.
Yeah, so the flat grid that they use goes to the centre of the ball, and then you plot the surface points on the ball.
Yeah, explain
as
that
if
one,
they're your
Brian. Go on.
points on your flat surface that you've
That's
taken the
not right.
measurement from in the first place. Is that what it's converting?
Yeah, it's like the zenith in the center of your Cartesian system will be pre-assumed afterwards mathematically to be diverging from all other zeniths in all other Cartesian systems and meeting at a central point. But that can't happen if you're going to use XYZ Cartesian, or even just XY, XYZ Cartesian coordinates. You can't do that because all the zeniths, all the verticals must be parallel, because you're dealing with squares and cubes, squares and cubes.
No.
No.
Oh my god. Because you use XYZ doesn't mean all the verticals have to be parallel.
No, it
Oh
doesn't.
my god.
I think he's thinking that they must be, but different systems they can be different directions. So yeah, go on.
I know what he's trying to say, but he said it in such a clumsy manner it came out completely wrong. He's trying to say that all of the z-axes for these various tangent planes have to be parallel. That's what he was trying to say.
Yeah.
Which obviously is wrong.
Yeah. It's an assumption.
Wrong.
Yeah. That's why we have different coordinate systems.
And cubed in 3 dimensions. So all those must. I'm going to go into it as we go on.
No, I didn't want to go further than that. I know where you're going. So I was just that point of principle where they're taking things from. So yeah, and that's cool then to make the statement diverging zeniths is fantastic. Yeah.
Yeah, should I even say it within this reference here, because they call it a local tangent or local geodetic plane. So in their mind, they're creating a big, huge tangent plane to do all this on, but really they're standing on a globe. So in their mind, they're...
But, Brian, that is the same thing. Or maybe he just... Yeah, I think I can see what he's trying to say there.
Doing everything on a tangent plane. That's how they try and explain it. And that tangent has to be tangent to a circle or a sphere. So that's what they're trying to That's what they need to say to make themselves believe that.
No, it's not to believe. It's to make the calculations easier, Brian. Imagine if we had to calculate for every step we made what the angle is to the divergent. That'd be fun, wouldn't it?
They're going to then put everything onto a sphere later on, and everything's fine when it's not. Do you know what I mean? The sphere part doesn't exist. But anyway, that's what they do. They beg the question is the easiest way around it. So next slide, please, Kiwi. Okay, this is a basic XY grid. There's no Z in this because it's only a two-dimensional. Earlier on, I showed the XYZ one, and I'll show more of them. But this is just basic. Backwards. So this would be +3 in parentheses and +4. That will give you that point that you see on the screen. So you'd have 3 across to the east, and then 4 up north. So that would give you that point there. Now, if you go on to the next slide, please, Kiwi.
It's like going back to primary school, isn't it?
This is what's known as polar coordinates, right? Polar coordinates are latitude and longitude grid, right? That's the latitude and longitude grid, right? That's why they're able to switch. So that's why the universal transverse Mercator map exists, because they're able to.
That is not latitude and longitude. That's a
no. It's not.
That is not latitude and longitude, dumbass.
He doesn't get it, but anyway.
To a Cartesian grid, but the universal transverse Mercator is a bit dodgy. I won't go into all the details now because it goes into celestial navigation and that. But and how to use it is a little bit dodgy. But the point is that polar coordinates are two-dimensional flat plane coordinates. Now, they often won't call the latitude and longitude grid a polar coordinate system because then they're admitting it's a flat plane. But that's where it comes from. It's a polar coordinates. And polar coordinates in 2 dimensions and XY coordinates in 2 dimensions work perfectly together. Because you can, as they're shown here, you could go across +3 and up +4 like in the previous slide, and you'll get a point on this grid that will match that grid. So that's how it works. So
you're muted.
Sorry. That doesn't make any sense, does it?
Yeah.
Or is he trying to say you'd be in the same position, but you wouldn't read the same coordinate, though? Like the polar coordinate wouldn't be the same.
In polar coordinates, you've got an angle and a magnitude.
But to get to the same point, it's not the same coordinate, is what I'm saying.
Yeah.
Yeah. That was what I was responding to, not the position. Yeah.
So it basically they work together. Now, obviously, there's no third dimension with latitude and longitude, because latitude and longitude is from celestials. So all you're getting is 2 dimensions. You're getting a 2-dimensional coordinate. You won't get an elevation. So in Google Earth, for instance, you'll get your latitude and longitude, and if you're looking at the bottom, they will say a height above ellipsoid. But ellipsoid is mean sea level. So when the surveying say height above ellipsoid, what they're actually saying is your elevation above or below mean sea level. So they're giving you your latitude and longitude, which is a point on a flat polar plane, a coordinate system, and then giving you your elevation. But that's only because they know the elevation, because they mapped everything out in X, Y, Z coordinates that they've then translated to polar latitude, longitude, and then they have the elevation that they know is there at that coordinate, so they can give in Google Earth, they can say whatever your elevation is above or below mean sea level. That's what they're doing. Next slide, please, Kiwi. Okay, this slide it just shows just kind of a comparison. This doesn't show the whole world, I think just the northern part.
Yeah, I wonder why it doesn't show the whole world.
But it shows basically how you have both grids working together here, just as an example. So there's both grids working here. You have the polar underneath the Cartesian. Next slide, please, Kiwi. Okay, Cartesian coordinates are like Russian dolls. You know, when you open up one doll and there's a smaller doll inside, and then there's a smaller doll inside that, and a smaller one and a smaller one. and you end up with a little tiny doll when you started off with a really big one. It's like that. So
That's
on
not.
this grid, you have the.
I know
all
what it's
the,
trying to say, but
this
no,
is
it's not.
Florida, I think. Now this is a nautical. I think this is nautical. This grid, but nautical use Cartesian as well. But here you can see I've coloured in where I've taken 4 of these squares that they have here, or rectangles that they're using here, and I made one bigger one out of it. But I can also take one of these and make 4 smaller ones out of it. So that's how it works with the grid, where with grid references, where because it's squares or cubes, that you can make them as big or as small as you need to make them. So any of this on this grid, you can take 4 of the big one here that I coloured in and make a bigger one out of it, if you understand what I mean. So that's how it all works. But what's important to note, the most important part is every corner, side, and every corner, side, angle, right angle corner here, everything has to go together. So this can't work over a curved surface because you will have distortions. So no matter where you go, each square or rectangle on this grid must equal in the exact size and dimensions to every other one. That's how that system works, right? So each one of these must match every other one. So if you're mapping the whole world out like this, let's just say if you were to do it from a North Polar point to start there, which they have done. It's called Grid North, right? They've done a version of it, whether it's
Grid North. Does he think that's what Grid North means? Okay.
the whole world, but they've done a version of it, and it's used by aerospace. Grid North. So basically, every.
Well, unless I'm mistaken, but when I started, Grid North just means the north that particular grid is using, yeah? Well, at least that's my understanding. Yeah. So there is no particular Grid North. So it just happens to be whatever north is for the grid. Yeah.
Every part of this every square or rectangle must match in dimensions to every other one. Otherwise, it doesn't work.
Do you think that's how he really thinks? That somehow that you must have divisions of that grid? I suppose it is. It's just like you can't comprehend that, what if you just decide to move a fraction of an inch? Does that mean it no longer correct?
You can't have diverging sizes. In reality, it doesn't work. You can't use it. And GPS, this is the coordinate system that GPS uses. It uses X, Y, Z. And it'll then convert to latitude and longitude and give you your elevation if it needs to. But it uses your X, Y, and Z. And the reason it uses X, Y, Z is going to become apparent pretty soon. So if you just go on to the next one, please, QE, next slide. This is an example of the type of things that you will get within GPS on your phone and whatever else. These are flat plane coordinates where they're showing elevations and that of different areas. This is a kind of a digital layout. It's called a GIS, but it's this type of thing you will get in your phone.
This is GIS, not GPS.
The main point about surveying here is that all the mapping, right, all the elevations, everything that is in GPS was all already mapped out and known before the creation of GPS.
No, it wasn't.
No.
What? What would be the point of creating GPS then? I hope he's not going where I think he's going, but let's see.
Now, my mother's partner told me even this when I talked to him. He said, yeah, the whole world was already mapped out, right? And every elevation known, right? Maybe not parts of the Congo or really northern Canada, but they knew all the surroundings, let's just say. So they basically had 99% of the whole world already mapped out before GPS turned up. They surveyed absolutely everywhere, right? That in the known world. So, and it's those mapping, all those maps, those ordnance survey maps that are used, were translated over into GPS and are used by GPS, and they use the same coordinates those maps were made in, which is X, Y, and Z.
No,
No. You go and Paul. You go.
absolutely not.
God. GPS doesn't map anything, Brian.
No.
No,
GPS gives you a point in space relative to the origin of the ECEF coordinate system. That's all it gives you.
Yeah. And
It
it's quite
doesn't know what's under that.
and it's quite clear he doesn't know the difference between GIS, which is what that image is talking about, and GPS.
God.
and
The
I'm
same
pretty
one.
sure that earlier surveyors didn't survey their things in XYZ coordinates.
No. Like,
I can damn guarantee you they didn't.
No.
well, they didn't when I was started. It was all bearings and distances and references, and there was very little X, Y, and Z. Not here
Yeah,
anyway.
there'd be some point on your map someplace tied to a latitude, longitude usually.
I started to use X, Y, and Z is when we started to get computer systems, and obviously it was easier in a computer to have an X, Y system. Like to convert that bearing and distance into a point, and you give the point a value. So, but that was before that. When we got a field survey from them, it was just all bearings and distances. So
Right.
we'd have to plot out from that. We didn't plot out X, Y, and Z. Yeah.
Now,
Well,
they
you're
will also
effectively going from polar to. You're effectively going from polar to a rectangular system
Well, that's when we went to
because of
computer.
that. That's
Yeah.
what a surveyor's doing.
Well, they do that now, but when I was then, we were still using the vector. So you draw your dot where your starting point is.
That's what I mean. Yeah.
Yeah,
Your
yeah.
instrument's sitting on a point. You turn
Yeah.
You turn an angle and you have a magnitude to the next point, the distance.
Yeah. Well, what I'm saying is you didn't convert it to an XY value because you didn't need to. Yeah, you had the next point, and then you went from that point to the whatever point using whatever vector. So,
Right.
yeah.
Right.
use polar, but it's primarily XYZ. And even Jesse Kozlowski, who is that geodetic surveyor on our opposing side who disappeared some years ago, that guy, even I have audio on my channel of him stating that the raw coordinates that come out of a GPS unit are X, Y, Z Cartesian and not latitude, longitude. So even
That's right.
he has to even
Yeah.
admit that
What's the origin though, and what's the reference? But anyway, go on.
That's exactly what they are. That's what GPS resolves a fix. It's in X, Y, Z Cartesian coordinates with in the ECEF coordinate system.
that's the coordinates are XYZ coordinates. From the raw coordinates that come straight out of a GPS unit are XYZ. And this is the digital layout that they create to go into that's installed into your phone and into GPS's units and whatever else. So I'll just move on, so not to spend too much time on it, but just that's the point. Next slide, please, Kiwi. Okay, this is basically what they would be trying to use from a center point of a globe, where you have a situation where they have this mean equatorial plane. Now, what they really mean by mean equatorial plane is the equatorial plane at equator. Oh, sorry, at equator. Sorry, at equinox. That's the equatorial plane at equinox, which means they can extend, which extends out into the celestial.
What? Equatorial plane at the equinox.
What does that mean? Does that mean
Hell, are you talking?
we only get it once a year, twice a year?
It's the equator, Brian.
I think I'm going to need some padding on my desk because I think I'm going to face desk in a minute.
The equinox doesn't have. Well, the coin to use one of Bev's favorite phrases has fuck all to do with this.
Yeah. No. See where we're at.
Plane, let's just say. So basically, they can make that as big as they need to make it, right? But the whole point here is that they're using azimuth, altitude. So it's alt-az. They're using an azimuth first and an altitude. This is their claim when it comes to satellites. They're using the alt-az system. So when they are getting an angle to a satellite, right, like they would say with the unit, they're using alt-az, which is, and the name of that system is the horizontal coordinate system. That's the name of it. So they're using the horizontal coordinate system, which is because XYZ has to be a horizontal coordinate system. It has to have XY is a horizontal plane.
What?
Is it? What's this horizontal coordinate system? Is that
Gee.
what the? It's International Reference System. Oh, I don't know what. I can't remember exactly what they call this, but yeah, basically the prime zero meridian and is the anchor point, as I like to think of it. But what's a horizontal? What there is no horizontal reference system that like a universal. Therefore, this is it. Type horizontal that I'm aware. Anyone aware of?
I never heard of it.
You've heard of it or never heard of it?
No.
I don't know where he's getting that one from. It's probably the same place he's getting this equatorial, the equinox plane from. Yeah.
Yep.
So and the Z, yeah. So they have to. So they're using the horizontal coordinate system with GPS. GPS as well. Something I said back some years ago in my presentation.
Hot mic, Timbo.
Thanks, man.
GPS, they say, stands for Global Positioning System, whereas technically it really stands for Geodetic Positioning System because it comes from geodetic surveying. That's basically where it comes from. So to call
You
it
don't
GPS,
get to rename
to
it,
call it the
Brian.
Global Positioning System, it's kind of not correct because GPS would be much more fitting if they called it Geodetic Positioning System because that's where they wouldn't exist without the surveying element.
Brian,
Okay.
wasn't it
Yes,
originally called Ground Positioning System before they officially named it Global Positioning System?
I think it was Arwen, actually. Glad you reminded. I remember reading about that before. Now, I haven't seen that recently, so I can't say for definite, but I think it was. I think you're right.
No,
And yeah,
it was never called that, ever.
No.
It was never called ground positioning or geodetic positioning. It was always called global positioning.
Yeah.
had other names
And
on
if
it.
you read that somewhere, Brian, you read it off of some bullshit flat earth website.
Yeah.
That somebody just making shit up.
It's just the usual thing if someone sees GPS and guesses what it means rather than actually finding out. So
It's those twats trying to get to obliterate the word global. They can't stand it. The word globe or globe.
Yeah, they had some other names. Before they decided on GPS being global positioning system, they had other names on it. And when I read it, I was like, no, this is geodetic positioning system. Makes more sense. But either way, it doesn't matter what they call it at this stage.
Isn't this over as soon as you mention if GPS uses Cartesian coordinate system? Isn't the jig up?
no.
That's what I
It is.
thought.
That was my point. That was my point in my presentations back in on surveying back years ago. But it just wasn't taken. People didn't take it and run with it. You know what I mean? It's
Because
like,
it's wrong.
Sometimes it's too simple. Like everything else that's simple, all the simple proofs are the best. And it's so simple that people just look past it. As I said, the whole chat were too busy arguing with George Netjuk and Blue Marble Science and Rumpus and everyone else at the time.
Oh, you got to
To
mention
pay
Blue.
attention to what was going on in the presentation.
You know, I like those simple things. You're speaking my love language.
Yeah, exactly. Well, all you need
Me
is
too.
XYZ. They're using, and I'm going to
That's
show
'cause
more
he's a
here, obviously, of a
simpleton.
lot of slides.
That's right.
Where they're using the horizontal Cartesian system. Or, sorry, the horizontal coordinate system.
Yep.
So, okay, we'll go on to the next one, please, QE. Next slide.
3 dimensions is 2 dimensions more than he wants to cope with.
Okay, geographic versus projected. Geographic coordinate systems, GCS, location measured from curved surface of the Earth, measurement units, latitude and longitude. So they're trying to hijack the latitude and longitude grid because they have to, because that's where their globe comes from. Degrees in minutes, seconds, decimal degrees, or radians, right? So that's what that's the way they will give them to you. Projected coordinate systems, PCS, flat surface, units can be in meters, feet, inches. Distortions will occur except for very fine scale maps. So see the way they must put in that part at the end, distortions will occur. They'll only occur when you're trying to force something to go back onto to go onto a spherical surface that it wasn't measured on. So yeah, you will have distortions because you're trying to make it.
No, it's the other way around, Brian.
Yeah,
Exactly backwards.
exactly. Yeah. How do you get distorted and then
As
you put it on a
usual.
globe? Yeah, go on.
As usual, Brian has got it totally ass backwards. This is what happens when you take measurements that are made on a globe and project them onto a flat surface, Brian, not the other way around.
Yeah.
Say that was priceless. Say that one more time.
Yeah, you're going to have distortions if you're trying to force something onto a curved surface that wasn't measured on a curved surface. It was measured on a flat plane. So yeah, you'll have distortions. Do you know what I mean? So that's what they try and say. They say every map is
Then why is it not distorted on the curved surface, but distorted on the flat plane, Brian?
distorted. It's only distorted because the maps they try and give you, they're starting off for trying to put that map on a globe, then flatten it out, then use real world measurements, and then distort those measurements when they put them back onto their maps, and then re-distort them again, or distort them a second time to get them back onto a globe.
What?
Just like in celestial navigation, all the measurements are on a horizontal plane, but then they put them onto the universal transverse Mercator map, which distorts them, and then they re-distort them again with the Haversine formula. And then they're saying all maps are distorted because maps are on the globe. Do you know what I mean? It's a no-brainer, like, isn't it? But that's what they do. This is unfortunately what they do. They do this to themselves. But yeah, technically, like, if I didn't have other information that was really important to give here, I could basically end it here because this kind of like says it all, doesn't it?
Yep.
Right? But because there's more to give, I'm not going to end it here, obviously. But I could just go, that's the end of that. You know. You're not going to think.
Yes.
Give it. I like the way, Brian, you hit on the point as you were saying there, that what they throw at us. Yeah, of course the maps aren't accurate because it's taken from a curved surface. It's a proper switcheroo, actually, the excuse we're given.
They pulled a 360 on us.
Yeah. Well, it's like wallpaper in my house. It's an old house.
They're ignorant.
A 360?
A 360, yeah.
You
bring it
realize
right
that's
back.
still going in the same fucking direction, Kiwi?
Yeah, it's back where we started, you know.
You're still going the same direction, right?
Yeah.
The walls aren't flat, but the paper pattern is. When you try to stick it on to wobbly walls, you get a mismatch of the pattern.
Exactly.
That you've taken.
Yes.
But you mean when you take that flat thing and then try to put it on something that's not flat, it doesn't fit?
Exactly, and that's why Cartesian coordinates don't work on a spherical surface, because they can't. Because the XY plane is a plane, it must be a plane. So when ballers say XYZ is global coordinates, they don't understand. No, the XYZ from their center point coming to the surface is not Cartesian, that is spherical coordinates. They don't even know, most of them, what the difference is between Cartesian and spherical. Because they just look at the diagram, it says XYZ from a center, and they go, see, globe. Because they don't learn. They just are told things and believe them, and then argue with us when we show them the problems.
Is it
but
possible
anyway,
that you don't get it, Brian?
One
Is
point
it possible
from the
you
beginning,
just haven't
a
worked it
quick
out?
question. When you're taking, as a surveyor, any of these measurements, what type of measurements do you take? Do you take them from a flat surface, or are your measurements referenced from the center of a ball?
No, you're referencing everything, and this is something that Bev has pointed out over and over and over. Like the tools used by what they call planar surveyors and geodetic surveyors are the same exact tools. You're either doing elevations, which is horizontal distances between parallel verticals, That's elevations, what's known as rise over run. Or you're using theodolites, which is
It's not
vertical and
rise over
azimuth
run.
angles. So how is any of that going to work on a curve? How is any of that going to work? They have to do everything in reality using a horizontal plane, using a horizontal plane and elevation as mean sea level as your basic horizontal plane, and all elevations above them vertical. Basic elevations are vertical. Vertical elevations above or below that point, below that plane, and they're using angles then with theodolites to work out distances between two mountains if you're doing geodetic. That's the only difference. Geodetic surveyors are doing the exact same thing as planar surveyors. They're up on a mountain looking at it using angles to get a distance, a somewhat correct distance between two mountains in the distance. You know, with an azimuth angle or a height of a mountain based off of a vertical angle using angular size measurement. That's what they're doing. Even my mother's friend, my mother's partner, even I went through it with him because he's an old-time surveyor where he did everything on pen and paper. He didn't even have calculators. Everything he did, he had to do in his head. Do you know what I mean? Because all this stuff came in as he was retiring. So, but yeah, everything is done on the surface.
Long before he retired.
Horizontal, vertical, and angles. That's all they do. Now, they have other systems that they use when it comes to total stations. Total stations will do distance measurements based off, kind of like, you know, those things you can get where you can get it uses triangulation where it sends out let's say a beam to a wall.
Like a rangefinder.
Rangefinder, yeah.
Triangulation.
I got one right here.
Yeah, range finding. That's what they're doing.
Nothing to do with triangulation.
Like calculations.
Dumbass.
That's what they do. But it's
Laser
using
range
triangulation
finder.
with that.
Yeah.
And that's how they do it. So with the more.
You'll have to get him to explain how you get triangulation with a rangefinder. How does that work?
Yeah, I'd love to. Know that.
Has time got anything to do with that? No. It's just triangulation, the angle. Yeah.
Well, up to date total stations, they'll do more than that. They actually map out. They literally, when you turn them in a 360, they literally map out what you're looking at on a screen for you.
No, they don't.
No, they don't. Which was that easy? Oh, gosh, we wouldn't have to spend, $20,000 to get a surveyor to do it if all he had to do was turn on the total station and walk away, and it mapped it out for him. Great.
They're worth a lot of money, but that's what they're at now because they're using GPS all the time. They don't need to do everything's already measured, if you know what I mean. So a lot of the stuff they're doing is only kind of like going over what they've done before, or for digital reasons and different things like that.
Brian.
If you know what I mean. But anyway,
we haven't measured everything. That's why we have to get the surveyors to do it, because it's not measured. I think he misunderstood that at a very early age. When someone said the world was mapped out, just meant they knew roughly where all the countries and everything was and boundaries and stuff, but they don't know where every speck of dirt in the world is.
hey, look, we'll move on because we can get into that conversation. Okay, next slide, please, Kiwi.
Yep.
Okay, here you have a situation where they're using, like they're trying to show a globe, but basically they're using a XYZ system from a center point of the globe, but really they're using the elevation and azimuth. That's what they're using.
No, they're not.
Basically, if you could picture somebody at the center point of that, with a GPS receiver, and they're getting an angle to something, whatever the thing we call it. I don't care. Call it a satellite, whatever. High altitude balloon, whatever they're getting the signal from, and then straight down underneath that will be the sub point, what they call a sub point. So in celestial navigation, a celestial body has a GP point. For something like an airplane or a satellite or balloon, it's going to be what's known as a sub point. So that's what that is. So that is basically they're working out through angles how it happens. So none of this is happening on a spherical surface. GPS unit is, it can't. I'll show in a while why it can't do this on a spherical surface. Okay, next slide, please, Kiwi.
I don't think he is going to, but he's thinking there's only one point. There's quite several GPSs to get that point. But anyway, signals. So anyway, we'll see where he goes.
Okay, there is a word here in both of them called relatated, and I don't know if it's a typo or if it's actually a word used within surveying, but it might be a typo used within surveying, because I don't know, I'm not used to that word, but I'll throw it in there anyway. Surveying is the art of determining the relative positions of different objects on the surface of the earth by measuring the horizontal distance between them. It is related only in horizontal plane. I don't know if they mean related or related, right? Leveling is out of determining the relative vertical distances of different points on the surface of the earth. It is related only or related only in vertical plane. So we're talking about a horizontal and vertical plane. That's it. So next slide, please, Kiwi.
Dear Brian.
I
Hello,
never
mate.
heard. One second.
Yeah.
Adam, have you heard that term before? Not to get bogged down with it, but I've never seen that term before in my life.
Not returning anything on the dictionary.
How many seconds would it have taken for him to work out whether it was misspelled or not? You know, if he actually did any extra research than looking in his Wikipedia page or whatever he got this from.
He's pulled a copy of a slide out of somebody's PowerPoint presentation and just had a typo in it.
Yeah, exactly.
It is related only in the vertical plane. It is related only in the horizontal.
Right. Yeah. It's a
It can
typo.
only be that.
Yep. Okay.
It's
There you
not
go, Brian.
Tit for tat.
Yeah, it's just a typo or whatever.
Yep.
Okay, here is I think one of my favorite slides ever, because this was the one I used back in 4 or 5 years ago, whenever it was I did the presentations. Here you can see what's actually happening. That green square on the surface of this sphere is actually down at the center, is really what's going on. But they're trying to give the impression that this up here, which is the zenith, is going to a central point of the globe, right? But the problem is that's just one Cartesian system. The one that's be directly below it, above it, to each side of it, and meeting it at each corner there, cannot be on a globe. It's not a disco ball. It can't work, right? As I showed earlier, all of these Cartesian systems must fit end to end, edge to edge, corner to corner.
No, they don't, Brian.
No, Brian.
They absolutely do not.
Why? Did it ever occur to him to work out that green square that he's looking at on his, how big that is relative to the world?
Well, yeah, that's another point. But I mean, regardless of how big it is, you can cover that thing with little squares like that, and you can put the little square centers a foot apart if you want to.
Yeah.
There's nothing stopping you.
That's what I'm getting at. Is it's just a matter of how big you want to make your grid, and the bigger you make it, the more distortion you're going to have from the as the further away you move from your reference center. So
that's why they don't make really big
grids. Yeah,
local maps. Yeah,
you can get. You know, that's why Australia's got 1, 2, 3. We use about 4 different zones to cover Australia. Britain's small enough to probably get away with 1, but even then they've got distortions in their grid when you read through the definitions. But anyway.
And they all must be exactly the same in dimension. So that's what...
Sorry, Blue?
We do them state by state.
Yeah. Well, some of your states have several grid zones within them.
Yeah, some of the states have more than one, but...
Yeah.
Yeah. We use a state plane coordinate system, and they don't line up with the coordinates of the adjoining states.
No.
Necessarily, you got to do a conversion to get from one to the other.
You want to say, Ellen?
Fortunately, our grid has its maximum errors kind of down in the Scilly Isles and up in the Shetland Islands.
Yeah,
and
but no one
not
cares.
very many people live there, so not that many people are too bothered by it.
They don't care that much.
Yeah, and they're pretty near all locals, so they know where the hell they're going anyway.
And when we're talking about errors, we're not talking about, kilometres out. We're talking about, we're in the millimetres.
A couple of 100 metres here, a couple of 100 metres there.
I don't think it's even 100 metres. I think we're talking millimetres. But I could be wrong about that. I know that central error is less than a millimetre for each grid. But anyway, go on, Blue.
No, the area in the British system is typically something like 2%.
All right. Yeah.
100 meters will be anywhere from 98 to 102.
Right. So
98.1 to 101.9 actually is what the
yeah.
Ordnance Survey guys told Bev. That's a 1 to 2,500, I think.
So that's in a meter zone, and then a couple of meters.
Yeah,
Yeah. Okay.
Boy, what they're showing here gives the game away. You don't need, if you understand it, you don't need anything else. Because all you have to do is take this square and put it down at the center point there and ignore this circle completely. Because that's basically what they're trying to do. They're basically, in some ways, they're partly hijacking the celestial dome model up to a point. Because they're using
how are we hijacking it if we're using
an azimuth coordinate system? But that says it all right there. So if we just go on to the next slide, please. So this is a very basic, just to show. All those squares have to be the same size. If they were cubes, they have to be the same size, the same dimensions. So H4 will bring you to there. That won't work on a globe, right? If you make this bigger, it won't work. And that's why they try and say, oh, it works for local level, right? But local, what's local level? 100 square miles or whatever? I mean, what's local level? I mean, you can't ignore curvature. If it's there, you couldn't ignore it. You certainly couldn't ignore it in an XYZ system. You can.
You can if the when you're working on elevations of differences of 10 meters over 100 meters, curvature doesn't mean squat.
Can't be ignored. You can't have diverging zeniths with an XYZ. The Z can't diverge from the other zeniths. And you can't have squares being different sizes and at different dimensions, or rectangles being different sizes or dimensions. You can go into Google Earth now and zoom in and you'll see they're not all different dimensions. They're all the same size because they have to be. Otherwise it doesn't work. That's the...
What's he talking about? What grid is he talking about? There's no grid on Google Earth. There's the only grid it shows is longitude and latitude. So, don't know what he's talking about.
That's the point. And that's how they actually measure in reality. They use that system in reality to measure. And that is the system used by GPS because it's the one that works. Now, obviously, latitude and longitude work as well, but not if you're trying to convert it back onto a sphere. Then you're going to have distortions because spheres distort, real measurements. Just like in celestial navigation. Yeah, isn't it? Just like in celestial navigation, you have to measure it on the horizontal surface of Earth and then bring it to the center of their globe at equinox, the equatorial plane at equinox, and then hijack the celestial dome model to measure an arc length. Sorry?
You can't have an equal grid size on a globe, basically.
No, you can't. Can't be done. That was one of my main points back a couple of years ago. But as I said, things like with a lot of things, people just don't pay attention when they should pay attention. Anyway, moving on to the next one, if you don't mind, Kiwi. Here is the Emerald Isle. This happened to show up. I said I'd take it. Here is Ireland in a grid map, right? And just so you know, funnily enough, Ireland was the most surveyed country back in the 1700s. It was the first country ever to be totally surveyed because the British came in here and surveyed the hell out of it because they had reason for it. They were, at the time, they were taking different minerals and trees and whatever else they were doing here.
Bloody English.
Adam Meakin and that Nate and Oakley. But it was.
I'd like to take personal responsibility for that.
You would, yeah.
Maybe reparations are due, Brian.
Yeah, maybe some reparations are due. But yeah, I just thought it was because my mother's partner. Now I don't go into the whole flat globe thing with him. I don't do that. I just talk to him about surveying because he's an older guy and it wouldn't be a good conversation. But
because he tell you where you were wrong. That's why.
Maps showing how Ireland was the most surveyed country. I think the first country ever to be totally surveyed, where they knew every single part of it, kind of thing. Because it's only a small place. Anyway, Ireland
when you say totally surveyed, what does that mean?
Yeah, that's Ireland. Anyway, on to the next one, please.
So there's no surveyors left in Ireland because it's already been done. Is that the deal? Don't need surveyors in Ireland anymore.
So here is Thailand in a grid map. So this is Thailand laid out in the grid map. As you can see, each one of those squares are all exactly the same size. So if you treat them as XYs, you can make any one of those squares into 4 smaller squares, any one of those squares into 4 smaller ones again, any one of those into 4 smaller ones, infinitum. So basically, this is how it works. This can't work on a globe. Ireland is small, and it wouldn't work on a globe if they tried to use XYZ on a curved surface. So I guarantee you, Thailand, which is not a big country, but it's a lot bigger than Ireland, certainly wouldn't work. Right. So there you go. How could this exist, and we live on a globe? You know, if that it just doesn't work. On to the next one, please, Kiwi. So this is I think this is Florida, and this is just an example. I think this is a nautical chart, but just to show that here you have again same situation where you don't have divergence in the squares. This is just as a representation of this type of mapping. On to the next one, please, QE. I had to add in America because QE is American and there's so many Americans here and people from the North America. So here you have similar thing where they're using a grid map across America.
That's not a grid. That's longitude and latitude. That's not a grid.
Now, a lot of the time when they're showing these grid maps, they're kind of relating back to the Universal Transverse Mercator map, which is a conversion from latitude longitude. But it doesn't matter. It's just a representation. On to the next one, please. Now, here is when it gets tricky. As you can see, they're trying to make it look curved with this one, right? This is the problem, right? This won't work. They try to make them look curved, some of these maps. They won't work if they're trying to curve them. What they do is they try to curve them left to right without curving them north to south as much. But you can still see there's divergence going on here, or they're trying to give the impression due to angle of divergence. But this wouldn't work. In reality, there's no way this map would work as a grid map. As all these lines would have to correspond to latitude, longitude from a center point.
They do they not?
They do. Yeah. In fact, I was going to say, I believe the Michelin maps, and they map pretty much the entire world, just use lat and long. So yes, you get a curving grid just like that.
Yeah. And the big giveaway, Brian, is the degrees written on the side, not eastings and northings. But anyway.
They couldn't work as a grid map unless, what I mean is that because there's divergence going on here, or they're trying to give the impression of divergence, which is basically what it is. It's a visual. I think this actually, most of this is just like a visual effect they're trying to give you that of a globe, when really it should just be a flat. They should just show it flat like it really is. So how it's really
it's longitude and latitude laid out on a flat map, Brian. That's what it looks like.
Or as a curved surface. I just wanted to throw that in just to show it, because people can see these things. You can see that towards the bottom there's one of the lines is curving. Well, that means it's a line of latitude then, because the grid maps don't have curving lines.
Correct.
You know what I mean?
So it's not a grid map.
They're kind of messing about with you with a map like this.
No, they're not.
Next one, please, QE. Here is I think that's Tampa Bay, part of Florida. This is somewhat messy, but it still shows that the amount of grid reference that goes on here. Now, you can't have any of that on a globe. It's not going to work. You're going to have too many distortions. I mean, around that area is not a small area. So in no time flat, 2-3 miles later, you're going to start having distortions.
Which is why they don't use the same grid.
Curvature is going to come into it if you're dealing with curvature. Next one, please, Kiwi. This is, I'm not going to go into too much of how because it's not important on how surveying use GPS, but basically they start off at a base station and with a known coordinates, and they're using rovers and moving away from that, and they can be up to big distances. Once they can get, if they're using microwave signals, their distances can be pretty big once they can get the signal to the base station. But basically, if you go on to the next one, QE, it's basically a way of triangulating. They're just triangulating. So they're going to throw in all these satellites up above, but I'm going to go through it in the next section. we'll go into more of what GPS is and the different
But how do we throw those satellites up there, Brian? They're up there. We don't throw them up there.
types of GPS. And it'll be like they always have to throw these satellites in up above here. I'm not saying there isn't anything in the sky that doesn't, like I would definitely claim high altitude balloons could help and other things. But the point is that it doesn't matter what's up there. The point is that it's mapping out a flat plane at all times. It's referencing a flat plane at all times. So just the last slide in this section, please, QB. Here is the portion of Coventry, some part of Coventry in England, I think. And this is a grid map where they are basically, this is on a smaller scale grid map. And this is how, if you were working in surveying, you'd be getting OS mapping, Ordnance Survey mapping. And it's these maps and with elevations and other things in it, obviously, as I showed earlier, that's what goes into GPS units. That's what they have. They have those. Now, they know if they know the coordinates on the grid, they also know on the Cartesian grid.
So why would we use GPS if we already know the coordinate? It seems a bit pointless, doesn't it?
Also know the coordinates.
Doesn't it kind of help you be able to quickly find the location on the map where you are?
Well, yeah, but he's basically suggesting that we already know where everything is, and they're feeding that up into the GPS, right? And so, like, well, why would you bother having GPS? You just get off your map. Why would you need GPS at all if that was the case?
Coordinates in latitude and longitude, right? But they are the coordinates that they're using all the time. They're always GPS is constantly referring to Cartesian and Cartesian only.
No, it is not.
No.
GPS isn't referring to anything. It's getting a position fix in free space, you dipshit.
Mm-hmm. And it's using several satellites to do it too. Is that the end of his presentation? That's on that.
No, I think it goes on forever. So I don't know that you want to go through a lot more.
Nah, it might be enough.
Please, that's enough.
Yeah, I think that's enough. I'll have a look at it and see if there's some stuff maybe pull out later. There's several hours more to go. That might do. Dear.
That's the problem with these flirts with their humongous, great long live streams.
Yes.
You kind of you can't cover everything. It's just too much.
Yeah. There's so much wrong just in that, but that's wrong, and then what he goes on to later on is obviously wrong. Competing navigation systems. I don't think they're competing. There's just different ones used by different people. They don't compete. Sorry, I'm just reading the screen. It says competing navigation systems. Yeah, yes. Brian Logic's not found. There is my what's his screen. So I didn't really get to say how you guys been during the week. Well, the last few days. Yeah.
I weighed 3,000 bucks today.
That sounds heavy, Paul.
Yeah.
One at a time, too.
One at a time. Absolutely, yeah.
Oh, boy.
Yeah.
You
Oh,
ever
Paul,
Yeah?
I saw the perfect gift for you on Facebook Marketplace.
What?
A first edition of a book called Raising Ducks for Pleasure or Profit.
Okay.
It seems to be some sort of standard
yes,
tome from the 1900s, I would think.
Okay.
I think I've posted it to not the book but the cover to Paul before. It's apparently pretty common.
Yeah.
It's often used in humorous circles. There's been a bit of a funny discussion.
We graved a bit about we grade them at about 5 weeks of age, right? And by that age, they're an average of about 1,200 grams, 1,300 grams maybe. But we get some as heavy as about 1,800 grams. But there was one today that only weighed 380 grams.
Ooh.
Boy.
Did he last long?
He went
Well,
to
she,
his
sorry,
maker.
maybe. Yeah.
She went to her maker. Anything below a kilo, we cull.
Could you automate the weighing process by having like a little runway and you have a weight and then you sort of get them to go down and stop them and then move them on? Or do you really, is it just not worth it? Just pick them up and put them on a scale and keep going?
Yeah, it's pretty... I don't know. It'd be pretty hard. Have you ever tried to herd ducks, Timbo?
Yeah. I was just thinking that would be the trick, is you'd have that one and, get going, come on,
Yeah.
go on.
It's kind of on a par with herding cats.
You just pick it up and put it on a scale in the end anyway.
Yeah, that's right.
I lost a screen. Why did I lose a screen? I can't see what's going on. Oh, dear. I think I just accidentally knocked out one of my...
And then I ended up with a bit of metal in my eye too. And, didn't know. I suffered with it all weekend and then went to the emergency department on Monday. They sent me straight down to the optometrist and took a chunk of metal out the centre of my eye.
That's no good.
No.
A big bit or just a little fleck?
Oh, it looked like they called it a big bit, but it looked like a little fleck. But I tell you what, it felt like a big bit.
Yeah.
Well, big and small, always relative, isn't it?
It is. Yeah, that's right.
I've just lost one of my screens, as in it's gone black. I can't see some of my stuff. So I can't click between things. Give me 2
You
seconds.
unplugged something, or
I think I accidentally kicked something out of the back, and I'm just trying to see what it was. Obviously, I know what it is since the screen went off. That it's obviously one of my cables out of the back of my video video cable.
I need to go because the noisemakers have just arrived.
ah.
Oh no. I might have to no. Oh no, it's on the wrong screen. Hang on a sec. I have to just change my settings. See you, Paul. Hey, noisemaker, how are you? Oh, Alan, I'll see you later. Let me just quickly do a little bit of flicking around here so I can see what's going on, or try to at least. That makes it a bit of a problem. See if I can get it to pull back my stuff. That's a bit odd. I pulled out one of the video cables and it still hasn't. It should switch and revert to 2 screens, but it's still trying to show 3 screens.
You've got a phantom screen, have you?
Yeah, but it's black, so I can't see what's on it. It won't disconnect. Ooh, that could be why it's got problems. I just pulled the adapter into the light and it's all chewed up. So I suspect
Chewed up?
Yeah, like the when I say chewed up, the connector where it connects onto the plug, just below all the plastic is all, and the insulation's all come away, and the shielding etc is all exposed. And I'm wondering if that's why it's not
You need a new cable.
Yeah. Need to do a little change in there. So that's frustrating because I can't see the OBS to switch because it's the screen that's got the OBS on it. It's gone off. So I can't tell it to switch. Come on. I'm trying to get it to ignore that screen so that I can see the OBS, but it's been a bit annoying because I turned the screen off thinking, okay, that should do it. Pull the plug out, that should do it, but it still thinks the screen's there even though it's not plugged in. Which is...
You don't have a spare cable?
I do. I was just trying to get something up so I can go and fix that while... but what I'll do is if I duplicate 2 and 3, then OBS will move over onto the screen. That'll do. There we go. Now I can see OBS at least. And I can put something on for a sec. I might find an Everett just for a moment while I pause in proceedings and get it. So Paul, just while I was going to ask you, do you have a quiz or anything tonight? Not that
No, I
matters if you
don't. I've been
No,
way
no,
too
that's all
busy.
right.
And when I had the bit of metal in my eye, I couldn't literally look at anything hardly.
No, that's no good.
Any bright light caused immense pain.
They're that is no good at all. They're oh, don't do that to me. Okay. Sorry. While I'm panicking here trying to find what I'm looking for. Let's go into here and do this. That is it. So they got any painkillers now, or is it just now that the metal's gone, it's all good?
Yeah, it's just sort of healing up over the last few days. They took it out on Monday, and it's only just starting to feel good now.
Well, I hope it continues to do that. I'm just going to switch to get over there if I can find that, and I've got to make a quick dash down the hall, and I'll come find a cable. I'll be back shortly.
Righto.
Hang on, let me play this.
So, the earth is flat, according to me.
You got the wrong number, bone brain. Where was I?
I believe that earth is forever expanding.
Do you do a lot of the drugs yourself?
I do, yes.
And it's infinite.
Oh my God. Look at that plastic bag. So beautiful.
So maybe the infinite parts can be only like spaces of water.
Okay, I'm very confused by what's going on here.
What you see here, it does not make sense.
Thus far, you have been adrift in the sheltered harbor of my patience.
We cannot say Earth looks like this, guys. We're not living on a round ball. When we say we're living on a flat Earth, it does not mean that it is suspended, like it's hanging in space. It's not a disc.
This throws my entire perception of reality into question.
Earth is not a disc. It's not just a disc that is hanging in space.
Not even gonna ask.
Space is like a blanket. So yeah, you can imagine Earth like that.
What?
It's a flat sheet that it's endless. no one can measure the horizons of the earth and sea.
We are not amused.
And now, the one I'm gonna show you now. This is more like it.
It's like I picked the wrong week to quit drinking.
So we're at the center of everything.
It's like I picked the wrong week to quit smoking.
And there is proof that the ice you see in Antarctica, that ice, it was put there by someone.
It's like I picked the wrong week to quit amphetamines.
The first area of the firmament is below the moon. So no one can go to the moon.
That is a lucid, intelligent, well thought out objection.
Thank you, Your Honor.
Overruled.
The sun is way too local.
It's like I picked the wrong week to quit sniffing glue.
Perhaps intelligent drones would have flown beyond the sun and show us the sun from above.
Hot diggity damn! This ain't no normal runt. I got me a bona fide freak. There could be money in this. Oh yeah!
You must spend a lot of time chasing stuff down to put in there. It's good though. I do like his stuff. Guess what? Can't find a video cable. But it's okay. Well, I can find 15 video cables. But what
not the right one.
I need one that's a display port. to get, I can't find. I track down 15 HDMIs and a couple of VGAs and several DVIs, but not a display port. So I'll muzzle just
muddle on.
Muddle on. That's what I was looking for. I did get to I got to ride my bike today with the electric bike to work because all the cars were taken, so I had to make my own way. My motorbike's still in the shop, so I had really, it was sort of like, I'm gonna have to try and ride my bike in, but it's actually worked out quite well.
The chain didn't break?
No, because I put a new chain on, so, and that was really nice and smooth. Of course, with a brand new chain, it worked really well actually. The only thing was when I got to work in the new office, they have a really silly. The architects made a big blunder when they were designing it. I happened to know because we'd spoken to them. I used to work in this building before, and moved in just when it opened, and so I knew about this problem, but I didn't. I hadn't catered for it properly. They, in their car park design, when they first did it, they had the end of trip facilities and the car parks all on the same level. And then at some stage they decided to split the levels so that they could effectively gain another half a car park floor. But when they did that, it actually shifted the end of trip facility down half a car park. So where they had designed it to be at ground level, pushed it about 3 meters below ground level. So instead of you coming in straight off ground level into the end of trip with your bike, you have to go down a stairwell with a 90-degree bend in it with your bike to get down to the end of trip. And they don't want people going through the foyer with their bikes to go in a lift. So when I first got there, and I was a little bit, I'm a bit unfit at the moment because I haven't been doing a lot of riding. Even though I got there fairly well on the bike, I was still, did have to do a little bit of exercise. and then I had to try and maneuver myself down the stairs with the bike, which of course is very heavy with the motor and the battery and all that sort of stuff.
Yeah.
But like it was going down, they do have a wheel track next to the stairs, so you can run the wheels next to it, but you're sort of trying to hold the bike, got the brakes on so it doesn't tear off in front of you, and get down the stairs at the same time. But luckily I worked out on the way out this afternoon that I could use the lift. If I used the service lift, you're allowed to use the service lift with the bike, which meant that I didn't have to go back up those stairs, which was a bit nicer. But I was fairly impressed with it, considering it's only a 250 watt motor. It dragged along pretty well, so I can only imagine what a bigger motor is going to be like. So it got me there. I was averaging about 25 k's, 25 to 30 k's most of the way.
Okay.
And I got a few big hills. It got down a little bit slow on the hills, but you could pedal, and that.
So third of a horsepower. I mean,
Yeah. That motor runs at about 90 newtons is the best it can produce. So the bigger ones do 110, 120 newtons of torque power. Yeah, but yeah, I thought that wasn't too bad.
250 watts is about a third of a horsepower.
Yeah. It eats less hay, though, I found. I don't need as much hay in my to run it. So, if that's about a third of a horsepower, what
is it, Paul? 746 watts is a horsepower, I think.
How does that relate to, say, a Newton pull or torque or anything like that?
Torque's not horsepower.
Well, no, I know.
They're different things.
No, I realise that.
Right.
I'm trying to position the horsepower into something that, because watts, obviously, to me, is a bit...
Well, I'll give you a physical definition of a horsepower. Is the ability to lift 33,000 pounds 1 foot in 1 minute.
Okay.
If I remember right.
Because what I was trying to translate is that because this is one of the issues I have with them using watts for the motor size, although it's in terms of speed, distance, and pulling power, there's so many other factors that come into it than just the watt rating on the motor. So
yeah, I mean the watt rating on your motors can tell you how fast you're going to use your battery, basically.
Yeah, exactly. So, because obviously I could change the gears on the bike because I still got the rear derailleur on, and if I put it in the bottom gear, obviously I can get and let the motor run at full power on a flat. I can easily get it up over 30 k's an hour. But if I drop that down to, but when I get to the hill, I found that the motor liked me to drop the gears down a bit, and then it got up the hill, as you'd expect. Then it got up the hill much better. So
yeah.
So that's where I find it interesting that that they're using this wattage as some sort of guide as to what's a safe motor to have on a push bike, as far as the laws go. So.
Harry. 1.5 pound.
Sorry, who's pounds? I can hear a voice.
Not me.
Not me. Must be Blue. Blue's the only one on here. Must be coming from Blue. It's all right. No, so let's work that. Okay. I'd still recommend it. I'm not sure long term whether I might stick it on a different bike than the one I've got. Been on the mountain bike. The mountain bikes were really lightweight, and it works really well on that. But I think it's one of those things that if I was doing it again and had money, you'd get a smaller motor with slightly different configuration for that bike. But it's smaller as in size, not smaller as in power. Yeah. But in terms of ease of setting something up, it's not overly difficult. Only recommendation is buy yourself a whole lot of cable ties, because you got cables going everywhere. You got to tie down, and I've been using the cable ties to work out where I want things before I fix them in place. But a lot of the times they're not going. I'm just going to use a cable tie to fix it in place. It's so much easier. I had my light on today. I had to adjust that, so I just grabbed another couple of extra cable ties and tied it to a different spot. But it was handy having the light on, because I was riding back. I decided to go a different way than I've normally done, and of course it was absolutely pitch black by the time I got through the suburbs, and there was no street lights at all in this area, and the only thing I had was the light on the front to work out whether I was actually still on the bike path or not. And I got, as I said to her daughter, it wasn't that I was lost, I just wasn't where I wanted to be. And I missed one or two turns, ended up in a different spot. I had to come back, and then ended up wandering around in the dark for a little while on the bike path till I got back to where I wanted to be. But it was literally pitch black, except a little bit of light in the distance, trying to work out, I know I'm on the bike path, but where's the turn? But I got home. I survived. At least I didn't have to pedal. It was easy. Well, I stuck the throttle on as well as the... So I can throw the throttle on when I want to have a little bit of a sneaky... little ride without having to pedal.
So you can bypass the pedaling thing,
yeah.
can you?
Yeah.
Yep.
Both work, and you can have the throttle on and pedal at the same time as well.
Yep.
It actually goes a little bit faster than if you just pedal with pedal assist only. But which was handy on some of the hills. But coming home, and when I went to work, I didn't use it that much. But coming home, when I was buggered after work, I would say that the throttle had a lot more use than it did when I was on the way to work.
Yeah.
And the battery only went down, so it's got 5 bars on the meter, and only went down for the day, went down 2 bars. So I figure, and that was with fairly heavy use of the throttle on the way home. So I figure you get about 3-4 days out of it.
And what sort of distance did you go?
I think it is 14 k's. I'm just trying to remember whether that. I think it's 14 k's.
Yeah.
I'm just having a quick look on the map. Not that map. It's part of the problem when you use mapping. Is when I type map into my Google, I get all sorts of different maps, like 6 maps and ActMapI and a whole lot of other ones, not just Google Maps.
Oh, just approximate will do. That's
yeah. No, I think that's about right there. I was just trying to remember.
So that's 14k round trip, or
yeah, I think so.
Yeah.
Yeah, it sounds about right. Just looking, have a quick look at that. Yeah. Yeah, that sounds it.
See, I'd be doing a 36k round trip to work and back.
I used to do that. One of my first jobs was way over on the other side of Parliament House, and I live on the far north of Canberra, and that was something like that, there and back. But I was much fitter in those days. But even then, that's where I think that I can see the advantage of having the electric bike in that case, that you can comfortably do that sort of trip without buggering yourself out.
Yeah.
So even then, you'd still only be charging, well, depending what amp hour battery you got. You'd still only charging maybe a couple of times a week if you're doing it every day. I've got a 12 amp hour battery, 12 and a half, I think. And with the fast charger I've got, it takes about 3-4 hours to charge.
Yeah. No, I'd be going for a 17 amp hour battery.
Yeah.
That's what I'm thinking of getting. Yeah. Yeah.
Yeah. Well, that makes sense.
Bit further distances in the country here, so.
Yeah, well, the batteries are the same, like physical casings are the same size, I found. It's just obviously the weight gets a little bit more.
Yeah. Yeah.
But since you've got a motor driving you anyway, the weight's not that big a deal, I don't think. It's sort of the inverse of when I was fitter and you'd get a bike, you'd try and save every gram on the bike, but once you stick a motor on, it becomes a bit irrelevant, really.
Yeah.
Particularly when you're only talking about a couple of kilos difference from the frame. Oh, well, I could carry on, but I was going to say, do you think we might call it a night?
That'd be nice.
Yeah, I think give it a chance to have a bit of rest. It's only a few hours. Now, I just got to find a screen to say goodnight to the Peanuts with. There you are, Peanuts. I see you. A big headlight needed. Yes. I do have a headlight that came with the bike. All the electric bikes tend to come with a headlight, and you can just turn it on at the on when you need it. And because obviously you've already got the battery, so you can have a fairly reasonable headlight on the push bike. And the switch is on the same controller that does everything else, so it's pretty easy. I do have a different headlight I'm going to switch out that has a horn button, so I can tell people to get out of the way. Anyway, I'll leave you guys. If you want to say good night, well.
Yeah, good night, Peanuts.
Good night, Peanuts.
Good night, Peanuts.
I will end the stream once I find the right ending button. There it is. Okay. Good night, Peanuts.
But you're on a bike. Just yell, "Hey, get out of the way!"
Well, I've usually run over the dog by the time that happens. That's the one I found really funny at night. Everyone's out with their dog, and the dogs, the really irritating ones. We have a lot of bike paths, right? They walk on the owner walks on the left-hand side, which is where we would usually ride, and they let their dog stretch out with the lead, taking up the rest of the whole path onto the right-hand side. So you come up to them and you're sort of very tempted to run straight through the middle and take the lead out and let the dog part ways with the owner. But no, the better people pull their dog over, but there's quite a few that walk that way and are very unapologetic. Anyway, good night. See you guys.
But yeah.
See ya.